Hi, everyone. Thanks for joining today's webinar, Finding Insider Threats, Digging Deeper. My name is Julie O'Shea, and I'm the Product Marketing Manager here at BlackBag. Before we get started, there are a few notes we'd like to review. We are recording this webinar, so we'll share an on-demand version once the webinar is complete. If you have any questions, please submit them in the questions window, and we will answer them throughout or in our Q&A at the end of the webinar. I'm excited to introduce our speakers today, Dr. Vico Marziale and Matt McFadden. Dr. Vico Marziale is our Senior Digital Forensics Researcher here at BlackBag, where he is responsible for R&D and supporting all of our software offerings. He holds a PhD in digital forensics and over the years has done forensics and general cybersecurity work, written open source tools, and delivered presentations and trainings at numerous venues across the US and internationally. Matt McFadden is the Director of Training here at BlackBag. After 17 years in law enforcement, Matt honorably retired as a police sergeant from the Clovis Police Department in California. For 13 years, Matt conducted digital forensic investigations and supervised their department's high technology crime team. He has provided expert testimony in state and federal courts for digital evidence examined in child exploitation, murder cases, fraud, and other crimes. Matt holds several industry-recognized certifications in digital forensics and incident response. Thanks for joining us today, Matt and Vico. Matt, if you're ready, I will hand the reins over to you to get started.
Yeah, thank you, Julie, and thanks everyone for attending. We're excited about today's webinar. I'm going to move ahead here. We are going to, a lot of things are going on in our industry, and one of them is going on is that our forensic tools are making our analysis easier for us. As examiners, this is great. We love it. But there is a warning here. You know, who's in charge? Is it the software or is it the human? It's kind of going to be both with what we do, but the tools are making for an easier analysis. Now, it's not going to happen all the time, but this has potential to put us in a point where we go, nah, I don't need to know that because the tool's doing it for me. And this can fall into something where it leads us to feel that we don't have to understand it. And we really have to step back and look at this to go, is our tool helping our analysis or is it replacing our need to know? And it should not be replacing our need to know, because if we're allowing ourselves to have a lesser understanding, we're not going to have those skills that we need to investigate. And we're going to review some scenarios here, but it's linking things together and piecing it together to actually dig deeper than the findings. We don't want the tool to provide us something and say, well, that's it. You know, I can't go beyond this. This investigative skill makes all the difference in your cases. And we're going to cover this as we proceed. We're going to cover just about 2 to 3 minutes of file system basics here. We're going to move into a couple investigative scenarios, and then Vico is going to take us on a even deeper dive into some really cool additional artifacts and newer ones out there. So reviewing of file systems, these are the base of what everything stands on. It tracks many required things in the computers we use. It tracks administrative information such as name, dates, times, and where this stuff starts. Where is our data? We have items that track the allocation of these storage blocks or allocation blocks or clusters, and it stores which ones are not being tracked or used. The last thing it does is our file all together? Are these allocation blocks all stacked together or contiguous, or are they broken up? And does that need to be tracked as well? So just moving through the 3 Windows-based file systems that we come across a lot, FAT32 is one of them that's still out there. It stores its admin information in a directory entry. It's a 32-byte directory entry, and we get the file name there. We get dates, created, last, accessed, and modified, and then we get where the allocation block or the first one starts, and then it's tracked from there. In the file allocation table, what we call the FAT, or when in FAT32 we get FAT1 and FAT2, the backup of it. But this file allocation table is going to track our cluster allocation of where this stuff is, and are these blocks available to use or not use. The file fragmentation is also tracked. It'll point us, whether to consecutive clusters or if they're broken up all over the place. The other one out there is exFAT. Now, exFAT uses, instead of one 32-byte directory entry, it uses 3 primary ones. There's a bunch of secondaries. I think it can support up to like 19, but we get 3 with each file that we save. The first one out there is a file directory entry. That little type code is a hex value 85 that we see on disk. But inside the file directory entry, we get our dates and times. In MS-DOS date and time format, it's where this information is stored. The second primary directory entry is called the stream extension directory entry. Again, a type code. In there, the big thing we get is the first cluster or starting cluster. And we also get a marker for, is it tracking any fragmentation? In exFAT, if it's not fragmented, it doesn't really see a need to track it, because it's going to say, here's where it starts, and just track on down to clusters that are all in line with each other or contiguous. The third is the file name directory entry. And this one's pretty simple. The file name directory entry stores our file name. You see it in the graphic here. This is where it holds. So as far as our cluster allocation, it's similar to the FAT a little bit. We get a file allocation table 1 that you see here where my cursor is. We get the FAT 1. We don't have a backup FAT inside FAT32, but as far as tracking which clusters are used or not, we have something called the alloc bitmap. Okay. Now, the last file system, I told you this would be short in the file system review, is we get NTFS. And we're going to cover this one. And the reason why I'm covering this is it's going to come into play in our investigation here. In NTFS, each record, file folders, they all have a base MFT record. They have one. You can overflow with these attributes into another one, but each one has a base MFT record. So if I create a file, it may get record number. These records are numbered. It may get record number, say 100. And it'll get a sequence number saying, hey, your record number 100, you got sequence ID 1 or sequence number 1. Now, if I delete this file, this MFT record space becomes available. It can be reused and a new record is entered, but it still is record number 100, but it'll say, oh, not sequence number 1, your record number 100, sequence number 2. And it's going to escalate up. And this comes into play in our investigation scenario here. You see across the graphic here, you see how we have an MFT record header. We have a, the sequence number is there. We get the file system ID is there. We get all kinds of good information. Standard information attribute, file name attribute, we get dates and times. Obviously, the file name attribute, we might have, we could have 2. It's going to have the file name. And then in our data attribute, we get where the data is stored. Is it inside this record or outside the record? Is it resident, non-resident? If it's non-resident, it points us out to the start cluster and where those clusters are, okay? The last thing here is just a quick snapshot of, this is a screenshot of Blacklight. And this is me clicking on a record or a file, and then I click the record tab, and you can see Blacklight is really going to parse out the data structure here. Automatically is going to overlay a template, and I have my data structure on the right. So let's start our investigative scenario now. Our investigation, this is a scenario in our upcoming Windows class. It's going to be released soon. We've got a guy working for a government agency. He's working in a secure building. And he goes over to his colleague's desk just to see if he wants to go to lunch. And his colleague has a laptop open. Laptop shouldn't be in this facility. He closes the laptop real quick and says, hey, I got to go to lunch. And he just takes off really fast. Well, his buddy's like, this is weird. So he reports it, finds out the laptop shouldn't be in this building. And we end up starting an investigation as to what's going on with this guy that kind of scurried out the door to lunch. Is there something suspicious here? So we've pulled his desktop and we're now analyzing it. Now, we're not going to throw you into shell bags without a quick explanation, like what are they, okay? And here's where they're stored. We got the path here. It's under the user profile. Oops, get my cursor going there. We have the user profile, app data local, Microsoft Windows, and user class.dat. The user class.dat is registry. It's where Microsoft lately has really been putting a lot of data in. And in the user class.dat, burrow on down, and you get into the subkeys of bag MRU and bags. Now, bag MRU is up on the upper left graphic here on the screen. And what we see is you see the 0, 1, you get the computer number of 10, but then 2, 3. And then below that, in each of the numbers, you see like a subfolder of 0, 1, 2, 3, 4, 5. And in those, you would see a 0, 1, 2, whatever. This is kind of a representation of the folder structure. Now shell bags is, shell represents like the window, and then bag is what we call a node slot, or think of it a bag that, it's a bag that holds the shell or window information. And each of them has and points to its settings. So you see here on the 0, 1, 2, 3, 4, 5 that we see the like payload and outgoing and Mimi and Bitcomet. Those are folders, and those folders are all in this number 3 folder over on the left, and we'd have to click in there to find out what it is. Now the MRU list X is most recently used. It's a list, and across the green line here, you see the 03 and 05 and 04 that I've marked out in the black little rectangle highlights. That's the number for the window above of the most recently used. Like number 3 indicates that the outgoing was the most recently opened folder, and so on. Okay. The last item is the node slot. You see the node slot up at the top, and you see node slot data 7. Okay, so inside that, basically that decodes to the bag. And here's where our bags are stored. So we would go for this folder, number 3, would go over and look at the node slot 7. And we get a lot of things of how was this window, what are the settings? What was the icon size? How was it sorted? Maybe where was it at? All the settings for the window. So looking at it, we're going to go look, and we're going to see how it parses it inside of Blacklight here. And I'm under System, Shell Bags, and I've got a bunch of folders. And in your case investigation, you're just going to start navigating around and look, and Blacklight is able to take this shell bag information and rebuild this folder structure here for us. And I'm just scanning around looking, and we know we got our guy who scurried out the door, and what's going to be something that is going to indicate our interest as an investigator. And right now, the word extract, that's not good, right? We're thinking, could this guy be stealing something? Extract, I don't know. It's not looking good right now. It's just kind of popping up on my radar here. So you can see right here, here's the bag path. We can see, remember that number structure 03 and the structure down to where it's stored. There's our node slot, 81. Get dates and times associated. Then over here, we get some really good information about this folder, or the shell bag data about the folder that, it may be on disk, it may have been deleted by now. Get a little B004 signature here, and I get some data. And if I want to look at it, I can click here, and there I see my extract. Blacklight's really good at, navigating you right to the data. And I get into, see the MFT entry number 113218 with a sequence ID of number of 5. So I'm going to go chase this down, 113218, sequence ID of 5. I want to go see if this is still present on the drive. Now, of course, I've been doing this before. We have a bunch of tons of filters that can help you, but I'm going to go in and get this back to where I had it, 113218, and I'm going to click filter or enter, and it's going to go out and query across, and yep, there's my extract folder still on the file system. So now we kind of want to look at this and see what it looks like within context to what's on disk. So I'm going to go reveal, right click it, reveal, and reveal in file browser. Blacklight's going to prompt me here to say, hey, you want to go on this volume? I'm going to say, yeah. And now I'm out there on the file system. I can see it in context. So extract through my name. I got some daily logs here. Got a js.zip file. Okay, this is interesting. I got some satellite intel, and our guy's working for the United States Space Force, the upcoming agency that should be coming out. But if I scroll down to the zip directory here, and I'm seeing satellite intel, exosphere, thermosphere, I'm seeing some things. I'm really wondering why this is in a compressed archive. Like, is this normal? Is this not? You can see Blacklight does really well, and it's parsing out. I can just go to the data structure and actually look at the structure of the zip archive too, but I'm not going to get into that at the moment. Inside of our other folder here, we find an other folder in extract. We have some captures. And these are looking like pictures. So let's look at these. And these are kind of looking like it's captures of like a desktop or a window. Like somebody maybe taking screenshots or something here. And so this is kind of leading us to, had some supporting slides here, but it's kind of leading us to what's capturing this stuff? What's going on? And so we want to ask ourselves, what could have captured these files, okay? So what we want to do is, we want to validate, we've got our extract folder, and we can validate quickly that we do have the right one. Remember file system ID 113218. Remember our sequence number was 5, and the metadata, we can validate the number 5 there. So we're on the right track, but we kind of want to get down to what is creating these capture files. Well, a lot of us would go, okay, well, there's that Windows thing, that snipping tool or whatever that is, right? And sure enough, that's a candidate. You can download, or get your Windows going and fire up the snipping tool, and the standard default save is capture with a capital C. So that's matching what we're seeing here, capital C. These are PNGs, but you can easily change the file extension there. So how comfortable are we at this point saying snipping tool did this? Well, I'm not going to be too comfortable just by a hunch. So we need to investigate. So we got to get back on our knowledge of what shows evidence of program execution. Okay. Well, Blacklight does a good job for parsing a lot of things for us. I can go under actual intel and user assist. Okay, let me click over here and talk about user assist real quick. User assist is stored in the intuser.dat. There's your path there. And this data is not stored plain text. It's stored in encrypted ROT13, right on table 13. It's shifting the characters to the right. It's like what we call a monoalphabetic cipher, real simple. And Blacklight is able to decrypt this for us, okay? I'm able to view it here, and right here under our nose is Snipping Tool. And I get it showing that it's launched. I have a username, USFJCrease, I get a count of 10, and I get a date and time here that's gonna help me track. Okay, this is a nice piece of evidence. So by itself, it's not a ton, but we want to lay it out related to things. So we're looking at a user. We get a username populated here by Blacklight, but where does this come from? Well, if we look at our artifact here, Blacklight is great because you always go down to the source. Down here on the bottom, you see it's USFF JCrease profile, and it's in his intuser.dat. That's where it's pulling this username from. So I'm attributing this to a user. And I kind of want to lay these out against what we know already. So let's go out there. We have user assist. Our date and time is there. And then we have our information from our shellbag data and the suspicious files that we found that are captures. So if we track it, we end up on January 24th at 2:17 Eastern time at 01 second. About 9 seconds later, we get another folder that's created on the file system. We get a shellbag entry created for that folder, okay? And then subsequently, within the next couple, 2-3 minutes, these captures are created. So we have Snipping Tool being launched, this folder being created, and now the captures are starting to take place within 3 minutes. So now we ask ourselves, how do we feel now? I'm feeling much more confident saying, yes, Snipping Tool is the one that was likely used to create these capture files. Now, one other question to throw at us is why is the shellbag, this is created 2 seconds later than the folder, which is on the file system. So these come up in court a lot where people go, wait, why is this after, and is that normal? Well, in this case, yes, the shellbag data is created once the folder is open. There's been studies showing other things. I haven't seen any evidence of that, but when you open this folder, the shellbag data is going to be written, and 2 seconds later, it's written to disk. So it is in line with how the act of the folder being created and opened a couple seconds later. All right, moving on to another scenario here, and still the same investigation, but we're going to look at Prefetch now. And our goal is, remember, we're trying to move beyond our findings, not just what the tool tells us. Let's investigate this. So Prefetch, again, we're not going to throw you out and say, just here's Prefetch, and I found this in Prefetch. Well, what does it mean? And that's the big thing that we need to grasp and understand so we kick in our investigative skill here. Well, they're stored, see Windows Prefetch. The name is application-name.exe-prefetch, hash. We'll talk about that, .pf. In the background here, you see the structure. I kind of laid it out in the gray background there. We're not really going to get into it, but you need to know there's a structure to it, and it's changed. And I'll let Vico talk about that. He's diving into some of this cool stuff. So out on the drive, we're going to find a Notepad Prefetch. So I'm going to take you back here, and this is easy under actual intel, and Prefetch is parsed right here. I can sort by name. A lot of things might jump out at us here, right? As investigators going, oh, look at that, right? But I'm going to scroll us down and focus us in on Notepad. Now it's loading all of this data, and we'll talk about what this means in a second, but I can end up getting folder paths, and I can get the name. Now, this notepad.exe is not the name of the prefetch, okay? The name of the prefetch is populated down here. I have notepad.exe, and there's my prefetch hash. This hash represents, it's basically a hash of the device-based path from where this application or executable was launched. So if I launch Notepad from another location, it would have the same name except for this hash value. It'd be different. And that would be an indication of, ooh, it's being launched from somewhere else. I may want to go investigate that. So we found this, and we can sort through and find some files, but what does this mean? What does this mean? And what do these files mean? What do these folders mean? Well, back over here again, we got to ask ourselves this question. So Prefetch is basically a mechanism by which when the application launched Notepad, and Notepad is telling like the cache manager, memory manager to say, hey, listen, Windows, I need this file, I need that file. You got to get all this stuff loaded up for me. So Windows is smart, and it's going to take a note, and it's going to monitor specific with applications. It's going to monitor that application for 10 seconds and go, what does it need here? And that's what we're seeing is this list of data that it's needing to pull and load into memory. So next time Notepad launches, Windows goes, oh, here's that guy Notepad. This is what he needs because I wrote it down on my list. Let's get this up in memory for him. And then Notepad's like, wow, Windows, you're great. You loaded this stuff for me. I can run a lot more efficiently, okay? Well, the cool side of the investigator aspect of it is we can use Prefetch and look into it and see what this application is loading as a resource. Not that it's specifically accessed, but the last time it was launched, it needed this. So going back and looking at it, I'm just sorting by name here. That's jumping out at me. I got a .reg file. Okay, I want to scan an asecurity, like what's that about? And then I got a couple text files. This could be normal or not, but we want to investigate those two. So I'm gonna start up here, and we're gonna take our investigation after this asecurity.reg. So first question is, does it exist on the file system? So we're gonna do that, reveal we could and go over, but I'm just saving time with some screenshots here. And we do find it on our drive, and we find this data for it. Now, looking at this data, we need to ask ourselves, what is this? Okay, a lot of you will recognize, yeah, this is a reg file, right? It's in the proper format of reg file, where we're either exporting a portion of Windows Registry, or we have a file we've modified. We're going to execute it with regedit, and we're going to launch it and do these changes. If we want to check, slide down here. Let me look. There's regedit prefetch, and we can look to see, did it load asecurity.reg as a read? Yes, it did. Okay, so regedit is playing with our buddy here, asecurity.reg. So what we have here is this, in the HKey current user of the ntuser.dat, we have software Microsoft Windows current version run. Now, again, what is this? We gotta ask ourselves and know this stuff. This is a very common auto run location. It's one of the most common ones. So when this user logs in, it's gonna load their registry and go, hey, run these things. So it has a couple items called Windows Security Firewall, Windows Security, and it's launching in those paths that you see a file called berry.bat and sentry.bat, 2 batch files. And even more suspicious, it's running them silently. Like, what's going on here? Okay, well, if we hop out to the registry, we just go to System Registry in Blacklight, navigate on down to our current version run, our auto run location. Sure enough, this is in the ntuser.dat. It's been written. So now this is, it's loaded, ready to go. So now I want to ask myself, like, what's in these batch files? Like, what are they doing? And we go out to the file system, we look at them, and here we get the context or the data inside. Now, berry.bat has this text, netsh advanced firewall set all profiles stayed off. I've used netsh a lot. I can't say I've really used it a lot for the firewall, but this is basically a command where we're trying to kick off all profiles, kill the firewall. Sentry.bat, it looks like it's adding a reg entry here to the Windows Defender under the software hive. And we've got a disable anti-spyware value being entered with a regd word 1, meaning yes, disable anti-spyware. So basically berry.bat trying to drop our berry, or sentry.bat's trying to drop our sentry. Is this normal on a user's computer? I'd be hard pressed to find a scenario where that's the case. Okay, so now we're going, something's really weird going on with this system. Okay, we can also look to see what else is going on. We have another one called jump list. Go out there. It's right here amongst all your program execution artifacts. I love this. And you can go on down to Notepad. Now, if you guys remember jump lists are Windows 7 where you right click on a application. It shows you your most recently run. It's basically a collection of link files that's stored in pretty much the link file location. I'm going to go to Notepad, and there we have a corroborating entry showing Notepad was opening asecurity.reg. So this is, kind of piecing us together. If we look at all of it here, we pop up our asecurity.reg file with our dates. We see that the file hits the system at 9:36:32 Eastern. We see within that minute, 15 seconds later, Notepad is accessing it, and then we have it modified, likely saved to the drive. So we're really telling a story here with our investigation about what's going on. Now, one more little chase here. We're going to go after this out.txt file from the Prefetch. So backing you up to our Prefetch, we found Notepad, right? And we found the asecurity, but we also found this file here, which is the outgoing, and then this is the folder, and then we have out.txt entry here a couple times. We have the folder path is the volume, okay, the volume ID or GUID, and then we have a volume serial number here. Now this one we likely don't have because this is looking like an external type drive, outgoing out.txt, but we're going to investigate that a little further, and then we have this one. So we're going to go chase this location, but we want to take a little note of this volume serial number 5056A672. So put that in your short-term memory. But we're going to go out here and we're going to look at these locations for our out.txt file. Well, we go out there and our out.txt is no longer present. It doesn't exist in the location where the Notepad was accessing it. So now what do we do? Where else can we look? What else can we rely on? This is where we got to use our brains and our investigative and our forensic skill to go, ooh, okay, well, let's look here. Walk in another evidence item, USN Journal. USN Journal, update sequence number journal, file system artifact. It's going to log, it works for the file system, but it works for applications too, to note updates to the master file table records for these entries. And it's going to log them down. Through here, what I did is went into the system logs and USN Journal and Blacklight. I did a Control F or Command F, depending on what system you're using, and I typed in out.txt. It's going to light it up yellow for me, and now I'm going, Okay, I got an out.txt entry showing me that it was on the file system, but then I got a .link file too. So what does that tell us? Right, we track that path to the right, and we see, well, it's in a user profile, app-dated roaming Microsoft Windows recent. Out.txt.link is telling us, yeah, the out.txt was open. A recent link file was created for it. We're going to come back and visit that in a second. But even better, the USN Journal is telling us a little history of the file across the file system is that it is now named $R random characters.txt. This is within the recycle bin from Vista on the recycle bin naming convention that happens to files. So let's go out there and look. Now back to Blacklight, actual intel, file knowledge. We have our trash items populated for us. This is not the recycle bin. This is Blacklight's parsing of it, which is nice. It's going to decode the $I file for our related recycled file. So we see our out.txt. We track it across. We see the original path, and then we get a deleted date and time. So it kind of helps us piece this together here. Now we go open up our out.txt file because that's big. Like, is this just an innocuous file or what is up with this out.txt? Does it really mean something to our case? We open it up and we see this. So now we're going, oh boy, you guys and gals out there that have worked incident response, any type case and have seen this, you're going, oh boy. Okay, this is basically a text dump of all the user profile passwords that in their hashed form. This is not good. So what now? Now what do we do? We found it. Now what do we do? Well, a lot of questions are surfacing now because we've got a lot of stuff we need to look at. What created this file? If I go to USN Journal, I got a lot of Mimi entries. Mimi lib, this is coming back to Mimi cats, which is a known credential dumping tool. But let's track it a little bit with a timeline here with what we know. Okay, our out.txt on the file system in the recycler, we got dates and times, and we have our link file right below that, and we have our USN Journal. So let's track it. File gets created on the file system, 105046. It matches our USN Journal. Our link file, okay, it ends up on our file system being opened as well. Okay, now we go over here and we look at our trash items, and we find that our out.txt ends up getting moved to the recycle bin at the same time and second as another application called pwdump7.exe. So we're going, aha, okay, maybe pwdump is responsible. This is a known credential dumping tool along with maybe ADLL, all these items that are related to it. So this is kind of pointing at pwdump as a player. Now, another item here comes back to our file system. Remember our MFT record and sequence numbers. Look at the USN Journal jump here. We have out.txt.link has an MFT record with a sequence number of 7, and it changes to a new MFT record. If we go over to the right here, we see file close or file close file delete. We see a new one being created. So this is telling me something's going on with this link file. Something changed. So I'm going to go out there and look at my link files. Again, I can go out here to file knowledge, okay, and I can click on link files and sort and find those, but I got a screenshot here for you where I have out.txt.link targeting the out.txt file, and it's showing it was opened on a removable drive now. There's our 5056A672 that we found in our prefetch, and it's stored in an outgoing file. So where's our data now? Yeah, this isn't looking good. It looks like Notepad looked at this on our volume from our prefetch, and now it's been copied over to removable device. It was looked at again, and who knows where it's at now. So we've got some issues here. We noticed a couple other things as we wrap up. We got some torrents that showed up in our trash items that we stumbled across, and that's the nature of investigations is you keep tripping on things. Oh, I need to go investigate that. Oh, I need to go investigate that too. Well, torrents are out there, and if we go look at the torrent file real quick, you ever done this in a case where you look and you go, oh man, the tool's not working. I hit hex and I don't see anything. Well, we look over here and we see it's 0 bytes. It's like, what's up with that? So I go investigate my torrent file further using the jump list, and I see 010 editor has accessed my torrent file. So why would they be using a hex editor to access a torrent file? Could they have used this and deleted all my data from it? The suspect covering up their tracks. Well, that's what happened here. One last thing, about 2 or 3 slides, is a memory dump. Just investigating and show you what Blacklight can do for you. This is a memory dump of just a DD. A lot of free programs will dump out your memory from your systems there. That's why it's very important to collect. You see utorrent.exe. We get the library, sockets, handles, all kinds of start time, process ID, parent process ID, path, parameters, all kinds of goodness. But focusing in on the sockets that this utorrent process opened, I see it actually was listening out here on a port for utorrent. This was the port that when I set all this evidence up, that's what I set for it to be listening for. And even better, we get handles. Handles is like a pointer to a place in memory, an object in memory, or something that it's relying upon, the process. And this process, utorrent, bam, it's just dropping us right in the middle of all of our satellite intel. And these were sourced to make our torrent file, and we're seeding these files through a torrent network. So just a quick recap is you can see how all of these things, just chasing shell bags, chasing prefetch, you can see how it just leads and spider webs out to just all these things we can chase. So I'm going to pause right here. Julie, I know you may jump in to see if there's any questions, and we're going to quickly turn over to Vico here if there's, see what we got.
Yeah, so we wanted to ask one question that came in before we switch over to Vico. What if I don't find any prefetch files?
Okay, so prefetch is it's typically going to be running. You can disable it by the registry and turn it off. That's an option. There's some research out there that I've heard. I had a colleague actually was assistant in a case that had a system with an SSD, and there was no prefetch. So I've actually tested systems with SSDs on them, and I've not seen the prefetch automatically turning off, but I've heard talk of that. But it's weird though, all the systems I've tested and I put in an SSD to multiple ones, I've never seen the prefetch automatically turn off. So I wonder if there's a setup program with SSDs that you'd run and say, hey, why don't we just, turn this registry value to not do prefetch. Also, did the bad guy or bad girl doing this case, did they go in to see Windows prefetch and just delete everything? That's completely a possibility too. So you always got to ask yourself, and it's good knowing how it functions so you can analyze it to go, is this normal or is this abnormal activity? So But I'll turn it over to Vico here. He's going to give us some really good stuff on diving even deeper with some of these artifacts and some really good new stuff here. So all yours, Vico.
Thanks. Get a little set up over here. All right, making some progress. All right, so Matt did a fantastic job taking us on a little tour of some artifacts that you've certainly seen and used before, but really kind of seeing what we can squeeze out of them information-wise. And in doing that, just to have a brief recap, he's showed us that we have an insider doing some naughty things, doing some things that we think are suspicious and some that's just outright bad. So he's using torrent applications and to access malicious files. He's using Notepad to access malicious files, taking screen captures. He's exfiltrating credentials, all kind of nasty stuff. And so what we're going to do from here is look at some newer artifacts that you may or may not be leveraging in your cases. And even if you are, we might have some new interesting details that you can use to again help you dig a little bit deeper into the artifacts and not just kind of stare at the basics. So first is the background activity moderator, or background activity monitor, sometimes we see it as. A process execution artifact started in Windows 10 in 1709, so that's the fall release of 2017. It exists in the system hive at the path you see up here, and also at the second path here, although the second path looks like it didn't start being populated until 1809. So be sure that your tools are updated to see where things are. Again, it's good to have a firm grasp of where these things should be and when. It's in the system hive, so it's not really attached to a user, but they were nice enough to put the SID of the user and then the name of the application and then the date that the application was run. So this is an artifact that you can use to add context to the things that we already have seen in previous slides from Matt. What does it look like in the registry? So in the upper left over here, you can see that we've selected the BAM user settings, and then there's a set of SIDs for keys, and we select one of the SIDs, and then on the right, we see the values for the key, one of which is regedit. The value data for that key is highlighted down below, and when we look on the data interpreter on the right, we can see that this is clearly a Windows file time, which is the execution time of the artifact, of the application. Blacklight will parse this stuff out for you in a sortable, filterable kind of way. It'll also show you the source file and all the other things like we've seen with the other artifacts that are off screen. If we blow some of this stuff up, so on the top, we can see that the user executed bitcommit. So we saw some torrent activity with muTorrent, but he also tried bitcommit a little earlier in the morning. That was at 9:15 on the 25th, and must have been unsatisfied, and then switched over to muTorrent about 20 minutes later, ran the installer, and then ran the torrent application itself. Also of note, not highlighted in that second picture, is the 010 editor probably being installed. As we move on down, we can see another execution time for Notepad, which we know was used to do bad things. Irfan viewer, which is an image viewer, which may be of interest to us since the user was exfiltrating pictures of satellite imagery. And then also snipping tool. So we saw that was used. And again, this is just another set of data that you can use in your investigations to add more context. Recent apps, another process execution artifact, but with a little bit more interesting stuff to it. So it stands for recent applications, and it's a really interesting name. What do we get? You get an executable ID, which we'll see what that is, and or the path of the executable, the last runtime, and the total run count. So this kind of sounds a little bit like user assist, but you can also get files that were accessed by that application, including the path, shortened display name, and the time that that particular file was accessed by that application. Where is this at? It's in the MT user hive, so we can attach this to a user at Microsoft Windows current version, search recent apps and a GUID, and then each of those GUIDs can potentially have a sub key of recent items with its own set of GUIDs, which will be the items that were accessed by that particular application. What does it look like in the raw registry? You see that we've got in the upper left, we have the recent apps key, has a bunch of subkeys, and we select one of them, and we can see an app ID of Blacklight. This is potentially from one of my research machines. A launch count, the app path is blank here, but that happens a lot of the time it's not a cause for concern. And then a last access time, where if we select it, Blacklight will show us the actual bytes, and if we decode the bytes over on the right, we can see that again, this is the time this particular file, this particular application was executed. If we go down a couple of entries, we see another application. This time we're looking at VLC being run. We see that it has an app ID and an app path and a launch count and a last access time, just like before. The difference here is that this particular guy has a recent items subkey with a GUID underneath it. If we look at that guy, then we'll see, in addition to type and points, which we don't care about for the moment, the path of the file that was accessed, the display name for the file that was accessed, and then a last access time. We want to make sure and not think that that might be the last access time for that image file. It's really just the time that that was accessed by VLC. It's kind of a misnomer. So Blacklight shows it to us just like this. Again, the key path, app ID, launch counts, paths, the times are there too, all this other fun stuff. So we can see that like Microsoft Edge was used to open these things. Up top, Windows Photos was used to open an HEIC file. VLC was used to open a movie file. This is all interesting stuff, again, to add more context and to see more file accesses timed by application by user. You might have noticed that none of these particular examples for recent apps have anything to do with the scenario that Matt talked about in the first half of this talk. It's because recent apps looks like it has stopped working as of Windows 1709 or so. So it's good to know that if you don't see data past a certain point, that's not necessarily a bad thing. It's like it's just been turned off, but you can still see data in there from versions before that. On that note, I kind of want to beat on this for a little bit, especially with Windows 10 putting out new revisions about every 6 months or so. These applications, these artifacts are changing more and more and changing faster and faster. So Prefetch is now compressed, which most tools will uncompress it and parse it for you just fine. But when it comes down to you wanting to go down to the bits and bytes and look and verify your results, now the file is compressed. So you're kind of out of luck a little bit in that respect. The Amcache was introduced in Windows 8, significantly changed in Windows 10, and then the changed version in Windows 10 was backported to Windows 7, causing dizzying issues. Even more dizzying, it's not even related to the Windows version. It's related to the version of the DLLs that are running on the machine. For anybody who hasn't read Blanche Lengy's Amcache paper, you should absolutely go read it. Shimcache has changed over time. USB device tracking changes constantly, but some of the newer changes are that there's a new place in the registry where device connections are stored for things that use the store port driver, like for larger USB devices. There's a new event log ID, 1006, that can give you device insertions and removals, and also things like the VBR and MBR of the drive that was inserted. You can have all kinds of interesting information in them. The point of which is it's kind of you need to be super aware. Things are changing more rapidly and more artifacts are discovered, and having kind of a deeper knowledge of what should be around and what shouldn't be around. If your tool misses a thing, is it because the thing isn't there anymore or because the tool missed a thing? It's super important to know. The next one we're going to talk about is a bit of a doozy. We're only going to be able to get through a small bit of what this thing can do for you. It's the Windows activity timeline, introduced in Windows 10. In case you don't know what it is at the beginning, if you click the little icon I have the arrow pointing to on the bottom, this shows up on the desktop. It's a timeline of what the user has been doing, so that you can go back and continue something that you've been doing. It also lets us go and look at what the user has been up to. It can be called the activity cache because the file is called activities cache. The Windows timeline, some of the APIs refer to it as an activity feed. So you see all of these words, they all really mean the same thing. It's really used for users to make things easier to remember what they were doing previously. The background here, it also allows activities to be picked up across devices so that you can be editing the document on one device, move somewhere else, edit it on another device pretty seamlessly. You can get between 3 and 30 days of history depending on some settings, which we'll talk about in a minute. So you may be wondering what exactly do you get, what's in there, why do we care? It can list applications that were run, and this is kind of important and interesting, specific times and like numbers of seconds when the user was actively engaged with that particular application. You can get URLs that like a web browser was touching, or files that were accessed by applications, and way more stuff that there's just never enough time to talk about. What OS versions? So 1803 through 1903, no longer pre-release, since I spent some time this morning looking at the actual release. So it is actually in the release. Just like every other app, the format, it's a database we'll see, but the format changes just a little bit in every single version just to keep us on our toes. It exists at the user home directory under app data local connected devices platform activity cache.db, where the question mark, the folder name there, changes depending on the type of user that's logged in. So if you log in with a local user account, that folder will be named l.the-local username, like for me, l.vico. If you log in with a Microsoft ID, you'll get this hex string that there's a way in the registry to map it back to a Microsoft, a string version of a Microsoft ID. Or if you're using the Azure Active Directory stuff, it'll use a different folder name. So you have to check all of these places. It is possible for the same, the same user profile to have multiple of these things populated. So that's something to be aware of. The file structure itself is a SQLite database. It is WAL enabled, so the write-ahead log, if you're using a tool to parse this, make sure that it's parsing the log, or if you export things and go stick it in a database tool, make sure you're exporting the WAL as well. The configuration is an issue here, and it's a little squishy, for lack of a better word. There's lots of different knobs to twist and turn to decide whether how many days of activity are going to be stored, and whether it's going to be synced across devices, and a few other things. So the defaults early on weren't to share everything all the time, but the defaults are changing now when you install Windows 1903, and maybe on a previous version, but I know in 1903, this is part of the installation process. So it immediately asks you, hey, do you want to go ahead and let Microsoft sync your activity and store all this stuff? And yes is selected by default, so we can safely assume that users are just going to go okay, which is good for us. The structure of the database, there's a handful of tables. This is probably the most important one. You can see that there are a lot of fields here, and some of which we understand pretty well, and some of which we don't understand pretty well, mostly because some of them I've never actually seen populated. Blacklight will parse this for you again with the same type of UI for everything else, with sorting and filtering and the source file and all the other fun stuff. So there are some important fields. So this relates to activities that the user is engaged in. You have a start time and potentially an end time. You have an app ID, which is the app that generated the activity itself. An app activity ID, you'll note that a lot of these fields sound the same. It makes it frustrating a little bit to play with this stuff. So the app activity ID is an application-specific identifier that usually relates to what the app was doing. Like it might have had a file open, and so you'll have the file path in there, or it might have had a URL open. You might have that in there. Then the activity type, which is really important. An activity type there are more than just 5 and 6, but these are the ones we care about. Activity type 5 means the user opened an app. Activity type 6 means that the user was actively engaged with the app right then. And then payload. Payload really relates mostly to how the tiles show up in the UI. But if you notice before, the tiles in the UI can show the application name, can show a file that was open, can show a website that was open. And so all of this stuff will be in there too. The E tag is also useful because these activities in the database tables can be updated, and each time they're updated, a global E tag thing is incremented for that activity. So if you order by E tag, you can get an idea of how things happened in order without having to rely on one of the many timestamps that are stored in the database. So how do we use this? If I want to know, like we knew the torrent applications were an interesting thing. First off, this is one row of output here. I've broken it up into two so that we can kind of see it a little better. So if I want to know what torrent activity has been going on, I can look at app IDs, search for anything that has the word torrent in it, sort this stuff by the E tag, and then start looking around. And what we see is some activity type 5 and 6s. And the first row, the one that's highlighted, we see that new torrent is running from the E drive. And then on the bottom, we can see the exact time that it happened. Activity type 5 means that it was open. So this is probably the installer for the file running. If we look at the second line, we see that now that muTorrent is running from the C drive, it's another activity type 5. So the application has been opened. And if you look on the bottom, you can see the start time for the application. And the third line is an interesting thing. So note that the activity type here is 6. It's for the same application as in the previous line. But if you look at the payload on the bottom, the type is no longer, type has user engaged, and it has active duration seconds and a start time and an end time. This is telling you that this particular user who runs this database was using this particular application specifically at the start time and for 345 seconds. The next 3 lines are further interactions with the same program. This got me a little excited. It was fun. Okay, so after torrent stuff, we know that the user also used Notepad. So we can again go look at things in the database that have a Notepad in the app ID. And again, if we sort by E tag, we'll see a bunch of activity type 5 followed by activity type 6 over and over and over again with start times and some end times. This particular one I have highlighted shows the payload below. Payloads are JSON blobs. So if you look at it pretty formatted down below, you'll see that the app Notepad accessed this specific file, asecurity.reg, which again we saw before. This is the one that that inserted some malicious registry stuff on behalf of our suspect. So you get that Notepad was used at a specific time specifically to touch that file, and you also get some interaction time after it. If we scroll through and look at the rest of these, you'll also see that the user opened out.txt on the C drive with Notepad at 1550:52. So just another corroborating result that the user touched it. And just as interesting, the user opened it again after he moved it to the E drive in the outgoing.txt folder. So this out.txt had the password hashes in it. So you can actually see the user opening Notepad and touching the file on the C drive and then it having been moved to the E drive. Snipping tool usage, same thing. We can look for an app ID that says snipping and see that the file is, at least as far as the activity database is concerned, was opened once. We have one activity type 5, and then several activity type 6s afterwards. The user opened it and then interacted with it several times. Unfortunately, if we look at payloads for all of these things, they look like the bottom picture, and we don't see anything about the files that were accessed or created or touched or anything. That happens for some types of applications. It seems a little arbitrary at the moment. But we do know that this tool, by default, creates files that are called capture and a number. So you can see here, if you go, instead of looking for snipping tool in the app ID, you can go look for capture in the payload, and you'll see that there are 3 entries that have capture in the payload. One of them, the app display name is photos. That's the Windows Photos app, and accessing this file, capture1.png, at the time listed up top. There are 2 more times these capture files were accessed with a different application this time around using IrfanView. Capture 2 was accessed and capture 3 was accessed, and since we have this, we know exactly what times these things were accessed, and we can go back and look. Like right now we have the activity type 5s. We can go back and find the 6s and see more interaction type things. Okay, so I had a lot of information and went really quickly, but kind of in summation to wrap up, hopefully stressed to you that some artifacts have been around for a while and are very well understood, and we've kind of got a wrap on those. And that's great. That's good that we understand these things and the tools can do all the work for us, and it's perfect. Others are either new or just kind of complicated and have links to many other artifacts and just store way more information in them than most people know of or use. These things change over time. With Windows 10, they change really, really often. So you have to constantly look. I'll be spending a considerable amount of time looking at 1903 and trying to figure out, what Microsoft changed on us. And that knowing some of these details of where these things should exist in different versions, or if they should exist in different versions, knowing that Prefetch holds information about files that were open, knowing that you can look at handles for a process in the memory viewer and see files that were open. These things will aid your ability to really, really, really investigate, which will help you get to some conclusions faster and hopefully with far greater confidence. And with that, turn it back over to you, Julie.
Thanks, Vico. We've had a lot of great feedback and a lot of great questions come in already. People are really enjoying everything you guys have been presenting, so thank you. I'm gonna go over a few questions that came in, and just so everyone knows, any that we don't get to, we will follow up with you individually. So let's start with, should there always be shell bags on Windows systems?
I can jump in on that one. There should be. Granted, could someone go in and delete those, registry data? Absolutely. But I believe it was Vista, definitely an XP, but I believe it was Vista where these started to appear. So, examining Windows 98 or ME, you're probably not going to find it. But from Vista XP on, you should be seeing those things. Some questions comes up as far as retention of the data. I've not seen a real time where it times out and cleans up, but it's something that might have to be tested further. But in all the cases I've looked at, you have the user class.dat. The one I didn't mention is you get it also in nt user.dat, which tends to be more system type activity shellbag data, but you can find it in both locations.
Thanks, Matt. So do you get a new entry each time an executable is run, or does it just update the last runtime?
For which particular? For BAM and for recent apps, you only get the last runtime. The only way you can get any kind of a history would be by looking at volume shadow copies or backups that have previous versions of those keys.
Yeah, and if that relates to Prefetch, the Prefetch files through the testing I've done is it's going to update the Prefetch file. So if the process is launched from the same location, that device-based path hash will remain the same. The creation date of the Prefetch file will remain when it initially was launched, and it'll be last updated or modified. That date will flash to show you when it was last done. So it won't create a new one if it's launched from the same location.
But Prefetch, correct me if I'm wrong, can hold multiple times that the program was run.
Yes, it can. The latter, I can't remember where it switched, but it definitely will do that, yes.
Great, that clarifies some things. So which versions of Windows support recent apps?
Early versions of Windows 10, I don't know how early, through 1709, but it's important to note there that I have a couple of machines that have been upgraded from before 1709 to the newest versions, and that stuff doesn't get cleared out. So you might have, if you're interested in history from a year or two ago, that stuff is very likely still sitting there, if the machine has been updated, from a pre-1709 system.
Got it. So what kinds of activity can be synced across machines?
So if you log into, assuming syncing is turned on for the activity cache, if you log into multiple machines with the same Microsoft ID, then all of the activities that occur on each of those machines can be synced back and forth, including every application, everything that we saw, all of the application executions and file accesses. There's even, if you turn the right knob somewhere in the configuration, you can even find copy paste data that can be synced across. You can actually open up one machine and start editing a Word document, and if everything is configured right, you can copy something from that Word document, like Control-C, and then go to a Word document on another machine you're logged into and paste that same text. It's wicked cool.
That's great. So how long does it take to get a working familiarity with all of these artifacts?
I can jump in that from the law enforcement side. It takes time. This is not a field you jump in are instantly an expert. The tools help you, but it takes time. You know, year 1 goes by and you're like, okay, I got some stuff. And year 2 and 3 goes by and you go, whoa, there's a lot more stuff out here. And I'm on my 19th year in this field, and my feet have still not touched the bottom of this pool. You know, and if you think you got it, there's iOS upgrading and Mac OS and all kinds of devices and things changing all the time. So the encouragement is, you know, take a look back of the road you've traveled. You realize, okay, I have picked up quite a bit, but always be open to more stuff. And Vika, I'll let you chime in on this one too if you want.
If you didn't know that you were, that you signed up for perpetual learning, like every single day, you're in the wrong field. I mean, I would say focus on the ones that you use, you know, that you rely on the most often and make sure you know those well. And then it's a never ending thing to continue to have to learn new stuff.
And I know we are at the top of the hour, so I will finish up with one last question for you guys. Will BlackBag be offering any courses in Windows forensics coming up?
Affirmative. Keep your eyes out on our website, probably around July. We've been heavy at work. Some of the stuff has been pulled right from that course. We're focusing on a very investigative centered stuff. You know, we're going to give you the deep stuff. We're going to give you the stuff you need to know, but we're going to teach you to convert that into an investigative mindset to find and to track the data and evidence that you need.
Excellent. Well, thank you, Matt and Vico. Thanks for walking us through how to use Blacklight to dig deeper into investigations and how to find insider threats. For anyone who submitted a question and we didn't get a chance to answer it, someone will reach out, a member of our team will follow up with you individually. And also as a reminder, we've had a few questions come in about this. We will be having this available on demand, so we will send out the recording after this. If you're interested in learning more about any of our products or services, please email the sales@BlackBagTech email address you see on the screen. And don't forget to follow us on Twitter, Facebook, YouTube, and LinkedIn, and subscribe to our blog. Thank you all again for joining, and have a great rest of your day.